Welcome back. Having looked at the criteria and the mechanism for E1 and E2 and a little bit of knowledge about the type of solvents and the type of reactions they favor, let's actually look at some examples of what constitutes a strong base or a strong nucleophile. Now, if you notice something in all of these, you notice one thing, that they all have a metal attached to them. Okay, the metal leads to a positive charge, and the negative charge on the remaining of the component what makes it a good nucleophile. Okay, so for instance, I could give you NaOCH3 or NaOCH2CH3. Okay, the fact of the matter is the sodium is there, makes it a powerful oxide, which is a strong base. Okay, so that means this will be positive, this whole thing will be negative. Similarly, this is positive and this whole thing is negative. So whenever you have an alkyl halide, say CH3, CH2, Br, remember this Br is attached to this carbon. So this is a secondary, this is a primary, right? Primary and methyl alkyl halides almost always favor only SN2, right? And the fact of the matter is this, when say reacts with say NaOCH2CH3, what it means is that this is the plus. I'm going to switch colors as it's getting too purpley here. So this is plus, this is minus, right? And the fact is this is a strong base or a strong nucleophile, and this is a primary alkyl halide, not methyl, primary, because this carbon is what contains the Br, and it contains two hydrogens, right? So the nucleophile is O minus CH2 CH3 that comes in. So this is an SN2 mechanism because this is a primary alkyl halide and it's a strong base, and it attacks this carbon, and in the process the Br comes out. Let me actually take it a little slow here. So this is the nucleophile. It attacks this carbon, and in the process the leaving group comes off. All happens at the same time, which leads you to CH3, CH2. You attach the O, not the CH2 again, and then the CH2, CH3. There we go. This is an ether. What is it called? Diethyl ether. Of course, naming is not the important part of this particular video here. Now, in all these cases, you just put a positive charge on the metal. If you're still wondering what is metal I'm talking about, Li is a metal. So if I have LiCH3, okay, Li is the plus, CH3 is minus. NaCN means the sodium is a plus, the Cn is a minus. Okay, you attach through the C, not through the N. Okay, similarly, NaNR2. Okay, this is a plus, this is a minus. All of these are strong bases. I don't expect you to remember most of this, because the fact of the matter is if you see a metal, that's an automatic strong base. Okay, strong bulky base. This is the only one I really want you to know for all practical purpose of this class. There are more, but you know, this is the common one. This is called a tertiary butyl oxide or tertiary butoxide. Okay, and this is the only one. This is a strong bulky base. So when it reacts with a secondary or tertiary, particularly tertiary carbon substrate, like say for instance, this is a tertiary carbon substrate, right? Say this reacts with this, CH3. This is a nucleophile, but this is not just any nucleophile. It's a strong, bulky base or a strong, bulky nucleophile. So this attacks Now, let me step back. Now, this won't lead to an SN2. Remember, I'm going to give you the flowchart which will again help you remember all this. This is a tertiary carbon substrate, and it reacts with a strong, bulky base or bulky nucleophile. Means it would almost be guaranteed to have only an E2. Okay, and in the future videos we can look at some of the examples. All I'm trying to point out is the purpose of the base. Okay, so if you feel like how do I jump to E2, I've explained it earlier, but again I will explain it again with the flow chart. All I'm trying to establish here is the nature of the nucleophile or the base itself. Okay, these are the weak nucleophiles. Now ROH means, let's say I give you methanol. Okay, this is a weak base. It could be CH3, CH2, OH. That's ethanol. This is what is in your beer. And you have your H2S, H2O. All of these are, and then your thiols, and then all of these are weak bases. Okay, so say you have a tertiary alkyl halide and a weak base. Okay, of course there's no heat. Heat will make it into E1. So let's say we have CH3, CH2, C, CH3, Br, and CH3. And this reacts with, say, methanol, and say there's no heat. Okay, this is just, and then say maybe water. Say we do this. Okay, so let me change my color here to say blue. Okay, the fact is this is a tertiary carbon, right? And this is a weak base. The fact there is no heat indicates that this would be an SN1. And what happens in an SN1? Well, basically CH3, CH2, C, CH3. Well, your leaving group comes off first. That's the first step in an SN1 mechanism, which means you're left with a positive charge, right? Now, this is a small base, so it can attack from this side or this side, right? So you can have multiple options. Now, keep in mind, this is where the leaving group was. So this is your beta hydrogens, right? So these two are almost identical beta hydrogen. This is slightly different. So it has two ways you can go for. So one is the CH3OH, okay? Okay, CH3OH. This hydrogen, okay, if I can write it as, say, so let me use my black. So instead of it being CH3, I'm going to write it as CH2H. What happens here is this lone pair comes and grabs this hydrogen, and in the process, this bond comes over here. Remember I said when a bond comes in, it brings a negative charge, which neutralizes this positive charge, which will give you CH3, CH2, C, double bond, CH2, CH3, right? I mean, it could have also happened with this, but then they're identical, so we don't need to do it twice. Let's say instead of this hydrogen, if it's going for this hydrogen, which I'm going to write it as this way, okay? And then the methanol comes, okay? Grabs this hydrogen, then this bond would go here, okay? So that means this hydrogen would stay intact, okay? You can be doing both at the same time. Okay, I'm just writing the CH3 here. Now, we have two products, right? Which one is more stable? Well, this is more centered compared to this, so this is the major product. Okay, so either of these hydrogens could have come off, but then this is an SN1. Again, you first generate a carbocation and then the nucleophile attacks. How do we know it's SN1? Because it's a weak base and we're starting with a tertiary carbocation. Okay, that's the most stable carbocation. Okay, and then your secondary, and then say if you had heat here and we had a weak base, or no heat but a very, very weak, bulky nucleophile, which I haven't spoke to you yet. I've spoke to you about strong, bulky nucleophile. A weak, bulky nucleophile would be exactly the same thing as previous one, but except instead of a negative charge, it would look like this. This is a weak, bulky base. Okay. I'm going to stop here because the purpose of this video is just to focus on the types of bases and how the bases themselves can influence whether a reaction is SN2, SN1, E2, E1, etc., etc. Right? So in the next video, we're going to look at a bunch of examples, and then in the final video, we're going to summarize the whole concept with the help of a flowchart. Right? So stay tuned.